The engineering and design of the Smithfield Street Bridge is an amazing feat. The bridge is a lenticular truss bridge. A truss bridge is designed so that all the weight of the huge structure is supported by the connecting of the truss. The truss connects in a way where it forms triangular units for support and is one of the oldest known styles of bridges. As mentioned earlier, the Smithfield Street Bridge has been recognized for its remarkable engineering design and is the oldest steel-through truss bridge in the United States. It is also the only bridge in this country that has the over and under double lenticular design. The bridge consists of 4 lanes of traffic and 2 pedestrian walkways. It is one of the most used bridges in Pittsburgh. At one point, the bridge was used for Pittsburgh's streetcar system, which stopped being used in 1985 and was taken out in 1994 when renovations were made.
As many bridges do, the Smithfield Street Bridge uses expansion joints. Expansion joints are used to help absorb any shock that the bridge endures, assist in expansion and construction, and allow for slight movement in case of stress or any earthquake. During high temperatures, concrete and metal will expand, and during colder temperatures, contrast. The Smithfield Street Bridge used steel expansion joints at various points to endure proper stability. The definition of technology is any man-made object that makes one of the life's tasks simpler, and that is exactly what bridges do. The Smithfield Street Bridge connects the southern and the northern shores of the Monongahela River. If it wasn't for this bridge, you would have to take a ferry to get to the other side, which would make travel through Pittsburgh very difficult.
When designing such a bridge, there's a tremendous amount of math involved. All measurements need to be accurate for the bridge to be formed properly. When building a bridge, the main idea is to connect 2 points to make travel easier. Whether or not something will be passing under the bridge also needs to be taken under consideration with its design. The Smithfield Street Bridge is 1,814 feet across and has a clearance below of 42.5 feet. This is important when designing a bridge that it properly spans the whole way across. In this case, it is also important that it leaves enough clearance underneath so that boats are able to pass. When designing a bridge like the Smithfield Street Bridge, engineers need to make sure it is strong enough to support all lanes of traffic, which is why it was made out of steel. Steel was the strongest metal available at the time of construction.
The Smithfield Street Bridge's architecture is designed in Romanesque. Romanesque style, which began in medieval times, is characterized by semicircle arches and beautiful ornamentation. The Smithfield Street Bridge has great detail that can be noticed in its lighting and design. If you look closely above the arches, you can see the 2 crescents of Pittsburgh in Romanesque design. The bridge is a functional work of art that is used every day by thousands of people.
The Smithfield Street Bridge is currently the oldest steel bridge in the United States. The present bridge is currently the 3rd wide site connecting Station Square to the Smithfield Street downtown. The Smithfield Street Bridge is the second to last bridge that crosses the Monongahela River before it meets the Allegheny River to form the Ohio River. The first bridge in this spot was a wooden bridge in 1818 by Lewis Waring Wagg, but was destroyed in the Great Fire of 1845. The second bridge that was built to replace the wooden bridge in 1846 was a wire rope suspension bridge built by John A. Roebling. On the Station Square side of the bridge, commemorative sign honors this great achievement and reads, "Here in 1946, Roebling built the first wire rope suspension bridge to carry a highway over the Monongahela River. He also designed a bridge across the Allegheny River and a railroad bridge at Niagara Falls and the Brooklyn Bridge. The increase in highway and river traffic eventually made this bridge inadequate, which led way to it being replaced in 1883. The current bridge was built in 1881 and 1883 and was designed by Gustav Lindenthal. The bridge was widened twice, one in 1889 and one in 1911. The bridge has been designated a National Historic Civic Engineering Landmark and is recognized by 5 plaques that are visible on one of the major pillars as you cross from Station Square. The top plaque commemorates this historic bridge renovations that were made in 1994.